Paul, you've been quiet lately. What's going on? You thought I was mad at you? Why? I mean, why would I be mad at you? Because you don't know how to fish? Well, that's no reason to hate someone. I mean, or be mad at someone for. Besides, you can learn. You just have to jump on that learning curve. Welcome to another episode of the Mighty Code Coder. I'm Rob Fitzgerald, here to make you great and help you innovate. In this episode, we're going to continue our adhesive work in all of our respective classes. CS 101 will be starting with the history of computers and then how to calculate numbers in Python. AP Computer Science Principles will be talking about the importance of planning and sequencing their code in Scratch. And AP Computer Science A will take on the ever important topic of classes and objects. Remember, there is a learning curve to all things, not just computer science. So get ready for a steady and rigorous path, but enjoy the journey. Let's get going. Okay, so CS 101, or Intro to Computers, you are going to start this week in Unit 2, and you're going to do 2.1 through 2.4. The very first part of that is 2.1, History of Computers, or Computer History. And so you just watched 17 minutes of computer history, and it said basically upon successful completion of this lesson, you will be able to briefly describe the history of the computer. And then they wanted you to consider these questions. How has technology evolved over time? What makes something a computing device? And what was the earliest form of the computer and how it is different from computers you see today? And then down here in the summary, they actually have they actually answer that for you. They say that telex is one of the first ancestors of modern technology. And then if you click on this, you have this technology timeline that's kind of interesting. So in the 1930s, if you go to 1933, you'll see the telex messaging network comes online. Now, every time I hear a history of computers, things seem to change. It's like they're starting remembering stuff and who was doing what. And there was a lot at the time, and it seems like every time you do a history of computing, you'll see something different. And I feel like they're finally getting around the world to ask people where they were at with computers. Here's one by Belgian Paul Otlet. Had a modest goal of collecting, organizing, and sharing the world's knowledge. So basically like a search engine, one of the first search engines. Pretty interesting. 1934. You thought Google was ahead of everybody. And then Bell Laboratories started the relays for data transmission. And in 39, you had this robot. You thought robots were just coming out now. There you go. It was at the World Fair by Westinghouse. Anyway, interesting stuff by the Computer History Museum. You could take a look at that, but there wasn't really anything to do on this assignment other than go through and see where people are at. I see how they're giving this mathematician Charles Babbage, who invented the difference engine to compile mathematic tables, as like maybe the first computer scientist. I could like to think it's George Boole. Put some comments below and let me know where I'm wrong. But anyway, it differs every time you see a computer history. Anyway, so after 2.1, there's a little quiz to make sure you did watch the videos. Other than that, there's really nothing to do for 2.1 in the history. And then you get to this basics of calculations. Okay, so these videos will take you about 11 minutes to watch, which we only have 8 minutes left in class, so you'll have to watch them on your own time. I'll just show you where they lead to. Basically, they lead to how do you add numbers in Python. And numbers have to match, right? So you could add a integer or a float together, but you can't add a integer to a string, okay? Unless you try to cast that string as an integer, which I think they try to do right here. See this right here? Actually, they try to cast the number as a string and then add it to the string. And remember, when you add strings, you're adding a plus, and it would be at that point concatenation, that you're doing. You're adding two strings together. All right. So, and then Adhesive's trying to keep the ear sketch thing going, which I think is awesome. You guys love music, and computers and music, when they jive, I think that's a sweet spot. You'll see in the code itself, they're actually making the new tempo 100 plus 20. So they're doing some addition, and they want you to notice that, and then they want you to play this. Now, I played this, but I can't get it to sound. So maybe you guys could look at this, go into your own ear sketch account, and try to see if you could do that. I thought it'd be neat to go in here and change the beats per minute. All right, that's what this is, and that's the tempo, and maybe see if you could change that song a little bit, but it wasn't working for me. You guys try it. It's pretty interesting stuff. And so I wanted to do one problem with you, and so after 2.2, after reading and watching those videos, you could do the quiz that they always have after learning certain things. I like to work with these coding questions. All right, so here's a coding question. It says, ask the user to input an integer, print out the next three consecutive numbers. So sample run will be enter an integer, 4, 5, 6, 7. Okay, so if I enter 4, it wants 5, 6, 7. All right, so the very first thing you have to do is get an input statement. And you know that when you have someone input something from the keyboard, you have to give them a variable to place it in. All right, so I'll go number equals input, enter an integer. Now, some of you guys probably noticed that I'm doing this wrong, and I'm kind of doing it wrong on purpose because I want to see if you guys can figure out what I'm doing wrong. Okay, now it wants to print out the next three numbers. So I could go print number plus 1. Okay, and I could go print number plus 2. I think I like to space this out, keep things neat. All right, then I could go print number plus 3. Now, if I run that, it's going to give me an error, isn't it? You guys know that already. What's going to be the error? So let's go ahead and run this. All right, enter a number. I'll put 4. And let me scroll that in so you guys can see it. Number 4, and hit return, and error. Cannot concatenate string and int objects on line 2. Remember when we first did inputs? It brings it back automatically as a string, and if you want it to bring it back as an integer, you have to cast it. Now we're near Halloween, and you know that casting is just like putting on a mask. So I'm going to mask this string as an integer by just putting a parenthesis around it and put it inside an integer function. All right, so now it's an integer, and you could add that. So now let's go and run it again. Enter integer 4, hit return on the keyboard. There it is, 5, 6, 7. Okay, so that's just simple, not concatenation, that's addition in Python. And I think the next one deals with a decimal number. Do you want to know what a decimal number is in Python? It's a float. Okay, so work with that, and that will be it for you guys today. And try to keep up with that. Try to run that ear sketch, because that ear sketch is really, really kind of cool. So do exercise 2.2, question 1, and question 2. Okay? All right, so that will be it for you guys. Okay, so, do I have this mic on? I probably don't have this mic on. I gotta turn this mic on. Okay, so now I have another mic. All right, so I think I'm good. All right, so classes and objects. Now it's not that their videos weren't good. They talked about a house and blueprints, and I believe classes are like blueprints, but I use something called the Ford factory. Okay, so I'm going to start. This is going to be terrible. I'm going to draw a garage. Okay, and I'm going to name it Ford. Okay, so this is a factory where Fords are built, and then out of here comes a car. Oh boy, right? Okay, it's headlights. There's a, I don't know what that is. I don't actually know what that is. All right, so out of the Ford factory comes a car. Now, when I go to build, let's say we're going to build a Mustang. Okay, the great movie Ford versus Ferrari. Anyone see that? The Mustang actually beat the Ferrari. That's pretty amazing. All right, so let's say you're going to create a Mustang. There's blueprints for the Mustang. How to build the Mustang. Okay, one set of blueprints. That's it. That's what a class is. That's a class. Okay. All right, but they didn't build just one Mustang. They built 1 million Mustangs. They built over 1 million probably by now, right? So each Mustang is an object built from those blueprints. All right, this makes a lot of sense. Okay, I like it better than his house one. Okay, so let's just think the object that comes out of the factory is the object. The class files are the blueprints of how to make all these, and we got a ton of Mustangs that come out, and each one is called an instance of this blueprint. Okay, and so that's when you create an object, you instantiate it, you make an object out of it, and you can make many of them, and they're all instantiated out of the same blueprint. Now his analogy about classes or about houses, same thing. They have one set of blueprints and they just stamp a bunch of houses and those are objects. But he kind of ran into problems when he started saying objects or houses. And it's hard to see houses as objects, but they are. And you just turn them in a different way, and then that house looks different on your street, but it's the same house just turned a quarter turn. But okay, so his analogy makes sense. I think this is a better one. The Mustang comes out. Then when I look at the blueprints of how to create a Mustang, and then we just start stamping them out, and that's called instantiation. Okay? All right, let me undo that. The picture didn't come out as bad as I thought it was going to come out. All right, so now let's talk about computer science classes and objects, and let's draw two things, okay, that I think will clear this up for you. Okay, this is the stack memory. And you're used to stack memory, because remember, if you made an integer, an int, x, you had to say what type of memory it was. Okay? But you could only store one thing there. Let's say like the number 3. Okay? Or let's say you had an array, okay, and you named the array my array. Okay, you also have to say what's in your array. So you go int, and you put the little brackets, and that's saying it's an array. And you can put a lot of numbers in there. Okay, but still it's just numbers. And that just seems like, man, I want to put more, especially if you think about the Ford Mustang, it has tires, it has a serial number, it has a VIN number, right? It has numbers and objects, and there's tons of stuff. There's got to be a better way to store data. Okay, and remember, all this is data. All right, and there is a better way. So I can come over here and I could say Mustang. Okay, let's call it Mustang 1. And remember, this is the type. So this is the type. It's just the type of data. So the data is of type Mustang? Yeah, it's of type Mustang. You made your own data type. Okay? The problem is it's not stored here on the stack. It's stored on the heap. I'm not sure why they didn't go into this. I mean, I think they think it's too complex for you, but when you see it like this, it makes total sense. Now, these things don't put all the stuff in here, because remember, if you had a Mustang, you'd have to put the VIN number, is it convertible, what kind of engine it goes in, and that's not how it does it. it actually makes a pointer reference like this. Okay, it's a reference, okay, to an object on the heap memory. And then you have all kinds of stack type of data, like engine. It's going to be a, I'm not good at cars, but yeah, let's say it's a 350. I don't know. Is 350 anything? I don't know cars. That's an engine. Let's say it's convertible. Okay, let's say it has a VIN of 173A761. All right, and so it could, in this Mustang, it could have all those. Okay, it could have all those things. All right, if I create another Mustang, let's say Mustang 2, I could create another one, another object, okay, with different stuff in here. Or, why don't I just, aren't a lot of cars the same? They stamp them out the same. Why make another one? Why don't we just say this one's going to refer to this one? Okay, they both could point to the same object. All right? So anyway, you stamp all these objects out there. That is the object. It becomes an object when it gets instantiated on the heap memory. Over here, it's still just, you are just declaring it. Okay? You're declaring. But just like you declared X, you said X, and what type of data does it hold? Int. So this is Mustang 1. What type of data is it? It's a Mustang. A Mustang, what's that? Well, it's a class that we wrote. All right? And so I think this helps out with the instantiation and everything else. All right. So this is when you go to your code, this is happening with the word new. And you can put equals here, and when you say new, that's being instantiated on the heap. Okay? So I think we had a new scanner was one of the early ones you guys had. Okay, and I forget what's in the parentheses, but when I went to new scanner, a new scanner got printed up over here. The new word instantiates an object. Okay, so you instantiate an object. All right, you declare what type of class it is. Okay, make sense? So when a class becomes an object, it's instantiation, it's happened on the heap. Okay, so later on in this course, you'll start writing classes, and you'll start to figure out what you want in your classes. Now, go back to the Ford analogy. Ford's going to have different functions. One might be faster. In fact, the Ford that they built to beat Ferrari had a really souped-up engine, not a 350. It was probably something better. But its functions were different than the other one. So you can write different functions for different classes, okay? Or you could write different functions for different objects, okay? Or different objects take on different functions, okay? So that's my stack and heap memory. That is my class and object, okay? What's the other thing? Constructor. Oh, so in the class file, your constructor will tell people how to instantiate your object. So what you have to send to it to actually create it. But we'll do that one later. This should get you going with that, and use the videos that they gave you and my chart here. I don't know, maybe this one's more confusing than that, but this makes it all the difference in the world. Okay, is when you're creating this is happening with that new word. Okay, all right. So then I'll switch back over. How do I switch back over now? I think I got to turn this light back on, and I got to do this, and then I come back in this way. Stage right. Okay, there you go. I could turn that mic off back there, but maybe I don't. I don't know. There we go. All right, so there we go. And then CSA, you have to do a couple things here. Let's take a look at your modules. Classes are all the rage, man. If you understand classes and objects, you're home. It's the power behind Java. It's the difference between CSP and CSA. That's it. It's everything. CSP is not going to get into that. Okay. And they shouldn't have to. It's that learning curve again. It's too much. All right. You guys should be ready. You should have taken prior classes to kind of get you ready for this. If you didn't, then you'll have to go up that learning curve a little steeper and just tread your way through it. All right. So here it is right here. We are in 4, and there's that fast start lesson I talked to you about. All right. So it's kind of like a pre-test. Get going on that. And then here are this was how many minutes did I say this was of material? You had to be like 11 minutes. We just did a 5-minute board work, and now you're into Unit 2, Lesson 4, review questions. They always have some nice review questions. Here is that scanner piece, or that new piece, whenever you see that new. Okay, it's pretty cool. And they have some stuff you can read in there. I'd go over it. And then here are the review questions. They always have a review. And then here is the first coding activity, coding activity 1, and coding activity 2. Make sure you spend time reading this to make sure exactly what they want. And then make sure when you run the code, when you go to grading, watch what they're testing for. All right. And so you'll do those, and you'll be doing pretty good. You remember, you're trying to get through lesson 5 this week, right? Is that what I said in the pacing guide? Here's the pacing guide. You're trying to get, there's lesson 5, constructors. Okay, but for today, it's just classes and objects. All right, so I think that'll pretty much do it for that episode. If there's no questions, I'm looking in the comment code, seeing for questions. And CSA, does anyone have any questions? Okay. All right. If there's no question, that does it for this episode. Hope that you enjoyed it. Remember, always trying to make you great and help you innovate. So until next time, Paul, what seems to be the problem now? Oh yeah, I forgot. If you have questions, leave comments below, or go to the website at www.themightycodecoder.com for further information, or find me on Twitter at MightyCodeCoder. See you next time.